Hi, this is Eric White with Open XML Developer. This is the next screencast in a series of screencasts on writing recursive pure functional transformations. In this screencast, we need to talk about extension methods. And the reason we need to talk about extension methods is that extension methods are the means by which C# enables us to write our queries in the way that we really want to write them. It gives us a more natural syntax, and I'll show you what I mean by that. Extension methods might be the simplest of all the topics that I've introduced in this series. They're simpler even than lambda expressions, and you have to admit lambda expressions are pretty simple. They are certainly far more simple than the lazy, eager issue. So what exactly are extension methods in C#? Well, all they are static methods. So the question is, what do you do when you need to write a utility method for some particular class and you don't have the capability for some reason or another to extend that class? How do you write a utility method for that class? The most common way that you write a utility method is you write some static method, and this static method takes the type that you're writing it for as an argument. So, for instance, maybe we want to write a little example that takes an array of integers, and the first thing that this example does is filter that array based on some particular predicate. And then after filtering that array based on some particular predicate, we want to sort the results. So here in this example, there is a static method that takes an array of integers as an argument. It also takes a predicate as an argument, and it returns an array of integers as its result. And here I wrote this method using a stack, the generic stack class, just because that's the easiest way to write this in the shortest number of lines possible. I'm not really particularly interested in the mechanics inside this method. I'm much more interested in how you use this method and how you use this method to compose your query. So there's this method filter that takes the array of integers and returns an array of integers. And there is also the sort method that takes an array of integers as its source and returns an array of integers. And of course, you can see here that I certainly cheated. I used link to write that sort method by dotting into the order by extension method. But again, we're not really concerned about the implementation of these two methods. What we're concerned with is how we bind to these methods and how we use these methods to compose a query. Many, many years ago, when I was first introduced to functional programming, and this was way before we had such niceties as extension methods and closures and laziness and so on, people still talked about functional programming, and if you needed to write a query, you basically had to write the query inside out. And I'll show you what I mean by that. So here we have this array of integers, this source, and we want to first filter it, and then we want to sort it, and then we want to print the results. So first I'm going to filter it. So I'll say variable of the result is equal to okay, so we call our static method. We pass the source array to the static method filter. We also pass a lambda expression indicating our predicate or what we're going to filter by. And then we iterate through the results, printing out the result to the console. And if we run this, we see exactly what we expect to see. We see all of the integers in that array that are greater than 2. And now if we want to subsequently sort the results of that, then we have to surround the entire expression with parentheses and then call the sort method. And if I run it, we can see the results that we expected to see. The key point about this is that we had to write this inside out. The first operator that executes is the innermost parenthesis, in other words, the filter operator. And then the next one is the sort, which surrounds the expression that contains the filtered expression. Well, let's change this example to use an extension method. So the way that you make an extension method is you declare a new static class. The class must be public. The methods inside of it must be public. And I'll show you there's one little bit of syntax that we have to include when we're writing an extension method. So let's do that exercise. I am going to declare Now, one funny point about this is it literally doesn't matter what we call this class. It could be called My Extensions, or it could be any other name you want. It doesn't matter what the name of the class is. What matters is that the class is a public static class. The class contains public static functions, and we'll use this keyword in declaring the first argument to these public static functions. Let's grab our filter and sort methods. I'll copy them out, paste them into our static class. Next thing is I have to make them public. They won't bind properly unless they are public. So now we have a public static class, and inside that public static class we have two public static methods. And we now have to put in the little bit of magical syntax that makes these into extension methods. And that's by putting the this keyword in front of the first argument to the method. So now we can come down here and we can change our code to use those extension methods. And you'll notice that filter now comes up in the auto-completion for that source because that extension method is now in scope. And when I open the parentheses, filter tells us that the only argument to this method is a single argument, which is the predicate, as opposed to the two arguments up above. Because it's an extension method, this source here is an implicit parameter to the filter method. So now I can pass the lambda expression to the filter. And further, I can now dot into sort. And when I look at the signature for the sort method, we see here it actually doesn't have any arguments because the array of integers that returned from the filter extension method is an implicit argument to the sort method. And if we run it, we see the exact results that we wanted to see. So what this enabled us to do is it enabled us to turn our inside out query outside out. So one of the things that I often do is I change the way I format my source code, and I put a new line before each of the operators, and this lets me read that query in a more natural fashion. So we have the source filtered by some particular predicate and then sorted, and then we can see the results of it. That's all there is to extension methods in C#. And in fact, in JavaScript it's even easier because JavaScript is explicitly made for doing these types of extensions. So in this JavaScript example, first, the code declares the array of integers. And then, after declaring that array of integers, this code adds the filter method to that array. It also adds the sort method to that array. And then, after adding the filter method and adding the sort method, we can write our query in the natural form that we want to, which is we can say that the result is equal to the source dot filter, passing the lambda expression, dot sort, and then iterate through and write the results to the document, or in other words, to the browser window. And if we run it, we see exactly what we expected to see. This is the same result that we got for the C# program. These are the types of things that JavaScript does in a super easy fashion. Now, link.js, in other words, the JavaScript library that enables us to write language-integrated query code very easily, it has a more complicated or a more involved approach to these extension methods, but to be honest, it's not that much more involved. It's just standard JavaScript. Key point about this is that extension methods, or methods implemented in this fashion in JavaScript, enable us to write our queries in the most natural form possible. That's all I'm going to cover in this screencast. In the next screencast, we're going to dive into what purity is. The very title of this screencast series is How to Write Recursive Pure Functional Transformations. Key point about this is purity of functional transformations enables us to debug and write our transformations in the easiest way possible. See you next time.